Yo, what's up everyone, it's Peter here. And today we're diving deep into the world of data science interviews, specifically at the Google level. We all know those Google interviews are legendary, right? And when it comes to data science, your SQL game needs to be top-notch. Think of it like this, your resume gets you in the door, but your SQL skills, those are going to blow them away in the interview room. We're talking about handling massive datasets, crafting complex queries, and basically speaking the language of data fluently. Don't worry, I've got your back. In this video, I'm breaking down the 5 most critical SQL techniques that'll not only help you ace those interviews, but also make you a data-wrangling, query-crushing machine in the real world. We're talking window functions, advanced joins, subqueries versus CTEs, the whole 9 yards. These are the techniques that separate the SQL newbies from the SQL ninjas. By the time you're done with this video, you'll be well on your way to becoming the latter. So buckle up, grab your favorite energy drink, and let's get this SQL party started. Want to crack a Google-level data science interview? Your SQL skills need to be sharp, efficient, and practical. Today I'm sharing the 5 most critical SQL techniques for data scientists. These are the exact methods used to solve real-world problems, impress interviewers, and handle complex datasets like a pro. Stick around. By the end, you'll be one step closer to SQL mastery. Alright, let's kick things off with window functions. Now, window functions, they're kind of like the secret sauce in SQL. They let you perform calculations across rows of data, but here's the kicker. They do it without actually grouping those rows together. It's like having your cake and eating it too. Imagine you're working with a table of employee data, right? You've got names, departments, salaries, the whole shebang. Now you want to find the second highest salary in the company. This is where window functions come in clutch. We're going to use the rank function, and we're going to pair it with the over clause, and this is where the magic happens. The over clause lets us define a window or a subset of data that we want to work with. In this case, we want to rank all the salaries, so our window is the entire table. We'll order it by salary in descending order because, well, we want the highest salaries at the top, right? So, the query looks something like this. Boom! Just like that, you've got a new column called salary_rank. And each employee's salary is ranked accordingly. But wait, there's more. We can actually filter on this new column to get exactly what we want. Add a where clause to select only the rows where salary_rank equals 2, and bam! You've got the second highest salary. Window functions, they're incredibly powerful, and they can be used for so much more than just ranking. You can calculate running totals, moving averages, and a whole bunch of other cool stuff. Definitely take some time to really dive into window functions. They're a total game changer. Alright, let's talk about joins. Now, joins are like the bread and butter of SQL. They let you combine data from multiple tables, which is essential when you're dealing with real-world datasets. Anyone can do a simple inner join, but to really impress in a Google interview, you need to master the art of advanced joins. Think of it like this. You have a table of customers, and another table of their orders. You want to find the customers who made exactly one purchase. Maybe you're looking for those who tried your product once and never came back. This is where your advanced join skills come into play. We're going to use a combination of a group by clause and a having clause. First, we group the orders table by customer ID. Then, we use the having clause to filter the groups, and keep only the ones where the count of orders is exactly 1. Here's how it looks in SQL. Boom! You've now got a list of customers who made a single purchase. But here's where it gets really interesting. You can take this knowledge even further. What if you want to analyze their behavior? See what products they bought, how much they spent, or even compare them to customers who made multiple purchases. Mastering advanced joins opens up a whole new level of data analysis. It's about understanding your data, knowing what questions to ask, and then using joins to connect the dots and find the answers. Trust me, this is where you really start to flex your SQL muscles. Chapter 3. Now, let's dive into the world of subqueries and common table expressions, also known as CTEs. Think of these as your tools for writing cleaner, more organized SQL code, especially when you're dealing with complex queries. Imagine you're trying to calculate monthly revenue and then rank those months based on their performance. You could write a single massive query with subqueries nested within subqueries, but trust me, that's a recipe for a headache. It's like trying to untangle a giant ball of yarn. This is where CTEs come in to save the day. A CTE is basically a temporary named result set that you can reference within a single query. It's like breaking down a complex problem into smaller, more manageable chunks. So, for our monthly revenue ranking problem, we'd first create a CTE called monthly_revenue that calculates the revenue for each month. Then we'd use another CTE, let's call it ranked_revenue, to rank the months based on the revenue calculated in the first CTE. Here's a snippet of what it might look like with monthly_revenue as select strafe time, %y %nimen, order_date, as month, sum, order amount, as total_revenue from orders grouped by month, ranked_revenue, as select month, total_revenue, rank over, order by total_revenue desk, as rank from monthly_revenue. Select asterisk from ranked_revenue. See how much cleaner and more readable that is? CTEs make your code more maintainable, and they're especially useful when you're collaborating with other data scientists. Plus, they can improve performance in some cases. Chapter 4. Alright, now we're getting into the nitty-gritty of SQL query optimization. This is all about making your queries run faster, which is crucial when you're dealing with massive real-world datasets. We're talking about shaving seconds, even minutes, off your query execution time. Think of it like this. You wouldn't run a marathon with a backpack full of rocks, right? You want to be as lightweight and efficient as possible. The same goes for your SQL queries. One of the biggest things you can do is use indexes effectively. Indexes are like the table of contents in a book. They help the database find the data it needs much faster. Make sure you're indexing the columns that you're filtering and joining on. Another important tip, avoid using unless you absolutely need every single column. Selecting only the columns you need reduces the amount of data that needs to be processed. And here's a pro tip. Filter your data as early as possible in the query. Don't wait until the last minute to apply your where clause. The sooner you narrow down the dataset, the faster your query will run. Query optimization is a deep topic, but these are just a few key things to keep in mind. Always be thinking about efficiency and how you can make your queries run faster. Chapter 5. Alright, let's put everything we've learned into practice with a real-world problem. Imagine you're working for an e-commerce company, and they want to know the top 3 selling products in each category. Sounds like a job for SQL. We're going to use a powerful combination of window functions, specifically the clause and ranking. The clause is like a more granular version of. It lets us divide the data into partitions based on a specific column, in this case, the product category. So, within each category partition, we're going to use the function to rank the products based on their sales. This will give us a ranking of 1 to 3 for the top 3 products in each category. Here's a sample query to illustrate this. Select product_category, product_name, total_sales, rank, over, partition by product_category, order by total_sales desk, as sales_rank from product_sales, where sales_rank, =3, and there you have it. You've successfully used your SQL skills to solve a real-world business problem. This is what it's all about. Taking those SQL concepts and applying them to real-world scenarios. Remember, practice makes perfect. The more you work with SQL, the more comfortable and confident you'll become. And that's a wrap. We've covered some seriously powerful SQL techniques today. We're talking window functions, advanced joins, CTEs, query optimization, stuff that'll take you from SQL 0 to SQL Hero. But listen, acing those Google-level interviews, it's not just about memorizing syntax, it's about understanding the concepts, thinking critically, and applying these techniques to real-world problems. Just like anything worth achieving, mastering SQL takes practice. So fire up your SQL editor, experiment with these techniques, and don't be afraid to get your hands dirty with some real data. The more you practice, the more confident you'll become. And who knows, you might even discover some new tricks along the way. If this video helped you, imagine what daily practice could do for your skills. Hit like, subscribe, and comment with the toughest SQL question you've faced. I'll cover the best ones in my next video. Together, let's master data science one query at a time. See you next time.